So good morning, everyone.
Yeah, good morning, everyone. Welcome to our talk. As Ricardo said, it's beyond chat, bringing agents to Kubernetes. Agents are all the rage right now. I'm Nimisha. I'm an engineer at Confluent, where I help manage a large-scale Kubernetes platform where we deal with thousands of clusters at scale. I'm a member of the Cloud Native AI working group that was mentioned earlier this morning. And one of my interests recently has been using AI to help manage Kubernetes cluster operations.
Yeah, and I'm Nina. I'm an engineer at Solo, working primarily on AI gateway projects. I actually met Nimisha through the Cloud Native AI working group. We worked on some papers together, like the security white paper and agentic standards. And my interests are primarily around Ingress Gateway, AI agents, Istio, and I was actually the 133 Kubernetes release lead this past spring. So we actually have an interactive section this morning to get some audience feedback to motivate this talk. So if you scan the QR code, you get an anonymous survey that lets you enter your answer to this question. So,
no slides?
Oh, it's not showing?
Oh.
Oh, interesting.
There's a mirror thing on your map.
You guys see?
Okay, yay.
Thank you.
Technology. First of all, we have kind of an interactive component to ask you some questions. So the first question we have today is, how many times have you personally asked an LLM like ChatGPT, Claude, to help you debug code or infrastructure? So we'll give everyone a couple minutes to answer it. Some answers flowing in. So no surprise, AI Day, a lot of people are using AI to debug things day to day. So second question we have is, what CNCF projects like Kubernetes, Argo, Istio, Helm have you asked the LLM to help you with? I know personally, I've definitely copied YAML config into ChatGPT in the past and just been help me figure out what's misconfigured here.
YAML.
Yeah, so it looks like a lot of people are using it for Helm and Kubernetes. That makes sense. Some Istio, some Argo. We'll actually see Argo in one of our demos. Cool. And last question of the day. Do you think AI agents are, for infrastructure specifically, are underrated or overhyped? So underrated on the left there and overhyped. Yeah, so this was kind of, I think, what I was expecting. Oh, I guess it's moving around. So it seems like there's a mix of people who think agents are underrated. Some people think it's overhyped. Today, we're actually going to look at an example of an agent in action running in our cluster.
So to begin, right, why even bother about agents in Kubernetes? So chatbots obviously offer limited value in infra operations because they have less visibility of your actual infra. They're not really built to be cloud native. So the question we're asking today is, what if AI could automatically enrich its context using real-time data about your infrastructure as it exists? So how it started, chatbots, and hopefully how it's going is autonomous agents in production infra. So with that, we want to introduce this project called Kagent. It's a cloud-native sandbox project. In one sentence, it's a Kubernetes-native framework for building, running, and managing AI agents. So it's built to be declarative. It all revolves around custom resources and controllers. It takes care of all the orchestration pieces, so stitching together your tools with your models and bundling together your agent. And then you get a lot of Kubernetes features out of the box because it runs in Kubernetes, so security, scaling, and it has some cool observability too. The goal with Kagent is to define and run agents in Kubernetes easily and safely. So no better way to showcase this than with a demo. So let's get started with our first one. I'll explain the setup. It's a simple microservices application. And we're going to be pushing a Git commit to it that introduces a misconfiguration bug. And then we have Kagent installed in our cluster. We're going to be creating a new GitOps agent that has access to Kubernetes, the Argo resources, as well as GitHub. And the GitHub piece, we're going to be deploying an MCP server, the open source MCP server from GitHub that has access to read and write from the remote Git repository. So if you can see this here, this is our application, front end, back end, very simple, everything works. Let's go to our terminal and let's try to break it. All right. And let's see, this is the commit I think we just pushed. So it's just saying, yeah, just making some changes, it probably works. And that's the change, it's the wrong target port there. Let's sync this via Argo. Yep, and our service, oh no, it's broken. So now we're getting the HTTP 500 from our front end and back end. So now let's actually deploy a couple of agents. So I'm going to go to the Kagent namespace. If you look at the bottom terminal, there's a few things running there already. But we're going to be applying our MCP server, like I mentioned. So you see a new pod there, and our GitOps agent too. While they're coming up, let's go to the UI for Kagent. So yeah, this is what the UI looks like. Some of these agents like come out of the box when you install Kagent in your cluster. This is the agent we just created. It's not ready yet. Let's wait for a bit. Meanwhile, let's look at the MCP servers. So again, a couple of them that come out of the box with Kagent. This is the one we just created. So you get access to tools like creating issues, creating pull requests, etc., inside your GitHub repo. And let's refresh. OK, now our agent is ready. So it's like a chat interface, right? I'm going to give it a really simple prompt, very basic to begin with, like calling the front-end service at this URL. I see HTTP 500 errors. Everything's running in the default namespace. Help me fix it. So it's already executing tools, like it did this Kubernetes get resource call here. It's thinking and trying to execute more tools to get more info. And you can see on the right, it has access to these tools. So some Kubernetes tools and then some GitHub tools. So it already found the issue. It says your backend is listening on a different port than the target port. So let's nudge it in the right direction. It's trying to check out our Argo resources. Yeah, relying on an LLM in a live demo.
That's why I'm running for slow.
Yeah, so I'm just going to prod it in the right direction. I think it got stuck. I'm just saying, this is the Git repo name. Create a branch and create a PR in that to fix it. And it already created a PR, I guess. No, not yet. While we're waiting for that, let me give you a quick tour of the YAML I applied. So this is a Kagent MCP type resource. And the spec, sorry, not MCP, MCP server type resource. And the spec is very simple, as you can see. It's just an npx command deploying the open source GitHub server. And the GitHub access token is from a secret that's deployed in the cluster. And this was the other one I applied. It's a Kagent agent type resource. And then the spec contains mainly model config and a system prompt, as well as the tools I mentioned. So here are some Kubernetes tools. And then here are some of the GitHub tools. Let's check on our, oh, OK. I think it did create a PR. Let's see. OK, so this was created just now. Let's check the content. And yep, I think, OK, so it's changing the port that the backend is listening on. I think that should work. Let's see. All right, let's sync from Argo. All right, let's see. Ooh. OK, now it's healthy. Yeah, no, that didn't work. Sorry about that. I think what it has done in the past, let me show you some PRs from our demo that we ran in the morning. So it actually did the right thing earlier. It fixed the target port, which is what it's supposed to do. And I guess this happens. I should have set the temperature to 0 on my model. Anyway, yeah, so it more or less does the right thing. It tried. You can tweak your prompt. You can figure things like that out. But anyway, that was kind of supposed to be our demo. Okay.
Yeah, so we kind of saw what components made up an agent. In Kagent, an agent consists of the system prompt. So that was the big pile of text that was in the custom resource, the LLM. So there's a separate resource called the model config that kind of defines things like temperature, which we probably should have tweaked around, which model you're using, so like which provider, things like that. And then the list of tools. So that was like the GitHub MCP server and the built-in tools that came with Kagent. But you can also specify other agents in that tool list as well. So what happens when you actually define your agent custom resource for the first time? So that agent custom resource kind of has two main parts, the model config and the tools. In our example, we had the system prompt embedded in the agent definition as well. And then there's a reference to a model config resource that, again, is like declaratively defined in your cluster. This has like a reference to like OpenAI, Anthropic, Gemini, like whatever provider you want, and additional provider-specific settings. So each agent only has one specific model config, but you can reuse the same model config across multiple agents. And then finally, you have the tool list. So each agent can specify multiple tools. Kagent actually has a cap of 20 tools that you can specify, and the tools can be of type MCP server or of type agent. Cool, and then so now let's go into like a deep dive of what actually happens in your cluster the first time you install Kagent. So there's a lot of content on this slide, so we're gonna kind of walk through piece by piece. The first piece I'm going to look at is the Kagent CRDs and the controller and their relationship. So the four main custom resources that you will care about if you're defining an agent or defining tools are the MCP server, the remote MCP server. So the difference there is MCP server is something running in our cluster, like the GitHub example we just saw in the demo, and remote MCP server is something that's external. So that's something that is not necessarily running in the cluster. The model config, again, defines which provider we're using with which settings, and then the agent is the definition of that CR that we saw. So like the system prompt, the list of tools, and the reference to the model config. And then in the demo, we were using the Kagent UI to kind of chat with the agent, but you can also use the CLI to chat with the agent. All of that chat session information is actually stored in a relational database that comes out of the box with Kagent. And then through the UI, you can also edit resources. So you can create, delete, change your agents in the UI, and then it gets persisted in the cluster through the CR. So I can make a MCP server in the UI, and then it gets persisted as an MCP server resource in the cluster. The next component is the actual agent deployment. So the Kagent controller is watching for changes to the agent resource. When it sees an agent has been updated or created, it spins up an agent deployment related to that agent definition. Then when a user chats with the agent, that session information is stored, again, in the relational database. You can also do fancy things like having agents that call other agents. So in this example, I have like a nested agent that calls a sub-agent. And the way that Kagent does this under the hood is with A2A. So the A2A discovery piece happens with the Kagent controller. But once the initial discovery piece is complete, then all interactions between the agents going forward will be directly with the service name. Again, there's the model config component. So like inline in your agent definition, you'll reference a specific model config, and that will determine how your agent reaches out to the LLM. And then finally, we have our MCP server definitions. So again, these are all YAML. You define either your in-cluster or remote MCP servers, but you also can use the built-in MCP server tools that come with Kagent out of the box. One example of that is the docs2vec tool, which allows you to query a lot of different CNCF projects that have been scraped and vectorized and stored in a vector DB. We've kind of walked through like what gets installed, but I think it's also good to learn a little bit about the history of Kagent. So Kagent's a pretty new project. It was donated to the CNCF last spring. And the initial design was actually not the same. It was very similar to the diagram we saw before, but with one main difference. It was built on the Microsoft AutoGen framework. So it's still a declarative framework, but under the hood, it was using AutoGen to handle all the agent definitions. But a lot of community requests came in asking support for other frameworks. So Kagent was actually reworked using the Google Agent Development Kit, the ADK kit. And now you can bring your own agents to Kagent. So you can define agents with the ADK agent library, LangGraph, and CrewAI, and bring them to Kagent. And those agents will interact with the other agents you have in your system over A to A. So here's an example of a bring your own agent, so BYO agent. It's very similar to the definition we saw earlier. The main difference is you have the BYO type and the deployment image specified there, along with some environment variables. And this is really nice if you have an agent that you've externally developed, but you want to run in Kubernetes with the Kagent runtime. So again, this lets Kagent invoke your agents directly, and you can have cool setups where you have a nested agent that's declaratively defined in the agent gateway in the Kagent YAML definition, but then calls something that's a bring your own agent written in a different framework.
Yeah, so what really makes Kagent different from other frameworks is that it's built to be cloud native and declarative. So it's all familiar YAMLs and stuff that you're used to. You can apply your RBAC policy rules, all your Kubernetes things that you do already. It also helps you with repeatable workflows and easy distribution. So you can templatize your agents and tools. You're dealing with randomness less this way. And you can use version control or GitOps tools, whatever you need to deploy it. It's also very customizable, as Nina just shared. You can use anything as a tool as long as it speaks MCP. And you can also build your own agents using other frameworks and run them on the Kagent runtime. It lends itself to complex multi-agent setup. So our demos today didn't showcase A to A, but you can do some really cool stuff with that, like having dedicated or specialized agents for certain tasks. You can also do web search. And I want to call out this new integration called K-hook in Kagent that it helps you do event-driven agent invocations. So basically, you get to take the human out of the loop for invoking your agents, which is kind of cool. It's also really simple to build agents with this project. And then finally, it integrates easily with any CNCF project. We're going to do another demo with Cilium, but first we have to fix our previous demo. So bear with me while I do that. So I'm just going to revert that commit that it did earlier, because it was not the right one. Sorry, this one just. Yeah, I will. Sorry, this is just me reverting it. So don't worry about what I was doing there.
I think we have to sync it right again.
Yeah, I will sync it. But first, I'm going to go tell that agent incorrect.
I'm going to let it have a second attempt.
Yeah, fix the target port instead. Let's hope it does that. So it did find the error earlier, just didn't do the right fix.
I think we're also using a pretty small model. I think it's the 4.1 mini. So
yes.
Maybe we just should have sprung for a more expensive model.
Yeah. It's executing that tool. OK, 1 second.
I think we can reopen, maybe, yep.
All right. Yeah, I think it's going to do the right thing now. It's saying, I'm going to open a PR fixing the target port, which is kind of what we want.
OK. Made a tool call.
Yeah, it called create pull request. Yeah, OK, let's
see if this one works.
Yeah, this one is.
Let's see the diff.
This one is correct.
Yay. So it just took a couple attempts, but they got there.
OK. And let's merge it. Yes, it got there for sure.
Nice. Okay.
Sync it. And our application should be running. So wait for it. Now it's healthy. Okay, still doesn't work.
Do we have the port forward?
I do have the port forward.
Yeah. Did the reverse?
Oh, the port forward was broken.
Nice.
Sorry about that.
Okay. Yay! Okay, Kagent finally fixed it.
Finally fixed it. Anyway, this was supposed to be our second demo. I'll just kind of breeze through it. So let's look at our default namespace. We have a few pods running there, the front end, back end. It's like this setup. You can see some packets are forwarded across these pods. We're going to be applying a broken Cilium policy. So broken policy, and here you can see CNP. This is the policy we just applied. The only thing is, in the spec, the labels are wrong. So role front end should actually be app front end. So I'm going to go now to a different agent that we have in Kagent, the Cilium policy agent. I'm just going to tell it a simple prompt like, hey, I just applied a policy, but now my connection from front end and back end is broken. Oops. So help me fix that. And this agent also has access to a couple of Cilium tools and some Kubernetes tools as well. So it's checking the labels. That's what we wanted to do, checking the ports. Yeah, OK, check labels. OK, it's doing Kubernetes get resources. The arguments are, yeah, it's trying to get the policy. And so it's saying, shall I proceed to check the labels, or do you want me to check the ports? I'll just say, fix the policy. Yep, it identified the issue. So it says the label should be app role front end, but it has app front end. So now it's updated it. Let's see. Oh, yeah, earlier we were seeing some dropped packets because of the incorrect policy, but now the more recent ones are forwarded again. So I think it worked. OK, going back to our presentation. You can also integrate Kagent with other apps outside of Kubernetes. So there's a community example for Strava and also with Notion. And yeah, I'll give it to Nina.
And then we'll briefly talk about, like we saw Kagent in action, let's talk about some best practices if you want to build your own agents with this framework. So the first thing is the tool definition. You want to make sure your tool list is focused. What you want to consider the use case you're trying to solve. So in some cases, multi-agents make sense. In other cases, you might just want a single, simple agent. Because Kagent is declarative, you can have a version per agent and per tool, and also use built-in Kubernetes types like config maps and secrets for different resources you have. The system prompt that we saw in the demo was all inline, but you can also actually load it from a config map, which is really cool because then you can kind of build a prompt registry for your agents to use and kind of optimize your prompts per model. And then the last tip is model choice. So like not every model needs to be very expensive. Sometimes you can get away with using a cheaper model. Kagent also has a lot of observability. Observability is very important for non-deterministic agents like we saw because it provides visibility and auditability into your system. So the way Kagent does this is through emitting OTel logs and traces per agent. You can also get the benefits of a lot of the BYO agent frameworks, like if you're using LangGraph, you get LangGraph traces. Because Kagent is a declarative framework in Kubernetes, you also get a bunch of Kubernetes benefits, like you can define RBAC policies, and like if you're using like a service mesh, you get MTLS for free between your agents. And then, yeah, we have a couple minutes left, but I think it's important to highlight some.
Just to wrap things up, right? If you want to learn more about the project, go to the community website or get involved there. Look at the project on GitHub. And all of the demos from this presentation are available on this repo open source. And quick shout out to the MCP and Agents community party that's happening Wednesday evening. So if you want to network with more people working in this space and on Kagent, feel free to attend that event. And finally, we mentioned in the beginning, we're members of the AI initiative on CNCF. So there's a Slack channel on CNCF Slack. Feel free to join that one as well. We have bi-weekly meetings. There are some really cool demos most of the time, and people work on initiatives like the white papers that were mentioned. And also, feel free to leave feedback for this presentation. And yeah, thank you so much. We have some time for questions if anyone has any questions.
I think we're at time, actually.
I think we're out of time, but you can find us after the talk for sure.
One question, with time for one question, yeah.
Over there, Rajesh.
Thank you very much for your presentation, first of all. Really, really nice. I already use it for a bunch of stuff, not just for Kubernetes stuff, even external things. One quick question is, how do you see the ecosystem converging? Because there is Kgateway and some other stuff, KMCP as well, which is part of this project. How do you see this converging to, form a kind of more broad ecosystem that can take?
Yeah, I can answer that. So Kagent and Kgateway are separate projects, and I think it's kind of Kagent is responsible for the framework. So a lot of the egress use cases where you're configuring specific policies don't exist in Kagent because it's like how you're defining agents, how they're running in Kubernetes, but it's not the observability, connectivity, security components. So they work very well together. Like you can have a confederated MCP server defined in like Kgateway that you can use with Kagent, but you also don't need to use the projects together. Like you can use them on their own, and they're helpful on their own.
Yeah, I think we are out of time, and we can take other questions later. Thank you, folks. That was really cool.